This is Algebra 2, a trig, 1A, 1A. We're going to talk about absolute value graphs. So the first thing we're noticing here is the most basic type of absolute value graph. F of x equals the absolute value of x. So what do we know about the absolute value? What do we get when we think about the absolute value of -3? What is the value of absolute value of -3? 3. It would be 3. What is the absolute value of 2? It will be positive 2. Every absolute value always gives you a positive result. Okay, it's all about distance. It's not about did you go left or right. It's about how far did you go. Absolute value of 5 is 5. Absolute value of -5 is still 5. So when we're talking about the table for our absolute value graph, we're going to plug in x values and we're going to plug in or negative values and we're going to plug in positive values. So -2, -1, 0, 1, and 2. We could have spaced it out more. You could have picked any x values you wanted to. Now what happens when we take the absolute value of -2? We get 2. What happens? What's the absolute value of -1? Absolute value of 0. It is 0. Absolute value of 1. It is a positive 1. And absolute value of 2 is 2. So there's your table. Now we should be able to plot those points. Where'd that table come from? Let's look back at that real quick. We picked x values. I picked some negative ones. I picked some positive ones. I just went right in order. Okay? Doesn't really matter which ones you pick. If you do your calculations correctly, you could plot your points. I picked values that would fit on our grid. I didn't pick -10. It doesn't fit on our grid. So at -2, I go up 2. At -1, 1, 0, 0, 1, 1, 2, 2. What type of shape is this making? This is a V shape. Some people see a triangle, right? Some people see a triangle, but if we're thinking about a function would move towards the right, and a function would move towards the left. Try to keep mine as straight as possible. So that's what we mean by a V shape. So this is the graph y equals the absolute value of x. The graph has a vertex. That's this lowest point, a vertex at 0, 0. Notice that in an absolute value graph, we have two different slopes. We have a slope that's falling to the right, and we have a slope that's increasing to the right. So we have a slope that is -1, falling to the right, down 1 over 1, down 1 over 1. And we also have a slope that is up 1 over 1, up 1 over 1. So we have a positive slope going on, and we have a negative slope happening. Notice how the graph is opening upwards. For this parent function, it's going to open up. In the future, we're going to see it opening downwards. The domain. These are x values. Your domain are your x values. What x values can we possibly type into this equation? Is there any limitation? Can you type in, obviously we typed in -2 and -1 and 0 and 1 and 2. Can you type in fractions? Can you do the absolute value of a fraction? Sure. Can you do an absolute value of a really big number? Absolute value of 20? Of 100? Sure. So it's all real numbers. And there's this symbol that we can use to represent all real numbers. So you don't have to use all those letters. You could just use that symbol. The range. The range are the y values. When we look at this graph, does this graph cover any y values down here? We get no negative answers for this particular graph. So no y negative answers. Do we get 0? Yes. The graph becomes 0. That's the lowest point. And then can we get values that are bigger than it? Yes. And 3 and 4 and 5. Is there any limitation to how high that graph might go? It goes up forever. So it would be, your range would be y is greater than or equal to 0. That is using inequalities. Interval notation is going to be, it looks like an ordered pair. The lowest number is 0, and the highest number your range can be is infinity. It goes up forever. So we use the infinity symbol. We're going to put 2 brackets around it. We use a rounded bracket to represent what you can never reach. It's never going to touch infinity. Infinity is too far away. It's not a location. You're never going to reach infinity. You can always go a little bit farther. There's no set of zeros that is infinity. Okay? You can get exactly 0, so we use a square bracket to include 0. So that says that we go from 0 up to infinity. That would be your range.
Wait, why are you using a bracket?
We use a rounded bracket, parenthesis, because you can never reach 0. It never touches that location. And that's not 0, that's infinity. It never touches infinity. And we use the square bracket because it does touch 0. It ends right there at 0. It includes 0. All right. Here we get a little bit more complicated. If that was what's called the parent function, this is called a translation. This has the h and the k value. This is your standard form of an absolute value function. The h is taking it horizontally h units, and the k is moving the graph vertically k units. So if this graph moved over and up, the vertex is going to go with it. The whole graph moves. And if it's going to move h and k, your vertex is going to be the h number and the k number. Now don't get confused. This is not interval notation. So these are always parentheses. It'll take some time. This is not interval notation. This is not a domain or range. This is a point. We always use curves. So when we look here at this equation, this says x minus h. The formula has a minus in it. So this is x minus a positive number. So when this says a positive number, the h is actually positive. That's kind of weird. X minus h implies that the h was a positive number. We're moving it to the right. If it said x plus h, that meant you had minus a negative. 2 negatives make a positive. So x plus, perhaps 2, x plus 2, would imply that you actually go to the left. So here, when we add a number to the outside, when we add it to the outside, the graph is going to move upwards. That's pretty straightforward. When that's a number on the outside of the equation, the graph is going to move up. When we subtract a number on the outside, the graph is going to move down. This is where it gets confusing. When we add a number to the inside, when we add it, that means that h must have been a negative, because a minus a negative means plus. Minus a negative. Some people say that's two negatives make a positive. We've all heard that phrase before. So that would be a situation of two negatives making a positive. So if you're adding it to get that to be a positive, then you must be moving the graph to the left. Two negatives make that be a plus. If you're subtracting a number on the inside, then that's actually going to move it to the right. It's the opposite of what we think. It's the opposite of what it looks like. If it's x minus 2, you move 2 to the right. X minus 3, you move 3 to the right. But if it's x plus 1, you move 1 to the left. All because the original formula was a minus. All right, let's try this one. We're going to graph this equation. We know that the parent function, you can include this if you like, this is your parent function. This is what that simple equation would look like. This is what y equals the absolute value of x looks like. What does the h and k stand for? What is the h value for this equation?
1.
The h value is 1. Nice job not calling it minus 1. It is a 1. The formula is x minus h. So h was the 1. What's the k value for this equation?
3.
It is 3. So what does the h do? The h moves it horizontally. What does the k do? It moves it vertically up and down. Horizontally means right and left. Vertically means up or down. So we're going to take every one of the points of the parent function and we're going to move 1 to the right and we're going to move 3 up. Take the next point, 1 to the right and 3 up. The next point, 1 to the right and 3 up. All the way to the edge of your graph. Any point that you know for sure on the graph is going to move 1 to the right and 3 up. So there you have it. That is y equals absolute value of x minus 1 plus 3. Okay, we will switch to the back side. Now, only thing we're doing different here is we're going to bring in this concept of a. A is in front of our equation. It's still x minus h, the absolute value, plus k. The a is a coefficient. It's a number in front. So when a is bigger than 1, the graph is going to stretch vertically. It's going to get more narrow. When the a value is less than 1, like a fraction, it's going to be wider. And then if the a is ever negative, then it's going to reflect over the x-axis. So when we multiply by a number, the number affects the slope. When we multiply by a negative number, the graph opens down. So let's try this. If you like to put in the parent function, you're welcome to do that. That's what we did in the very first graph. That's the basic graph. You're welcome to use that here. I make it really light, or you can make it in a different color. It's not the main graph. You don't want to make it real dark in marker. All of these points are going to get reflected downwards, so the graph is going to open downwards, and it's going to have a slope of -2. So 0 times -2 is 0. -1 times -2 is -2. 2 times -2 is -4. So I'm multiplying all of these y values by a negative a value, by this a value, which is -2. Way that you probably want to do this is to look at it and think my slope is down 2 over 1, down 2 over 1. And then you have to go the other direction also. So there is your graph. Y equals -2 absolute value of x. For our last example, we're going to combine. We're going to have an a value and a translation. So we know our parent function is y equals the absolute value of x. When we talk about a concept called RST, that's giving us a reflection, and we get a reflection if the a value is less than 0. We have a stretch if the a value is greater than 1. So the graph is going to stretch and get farther. So we saw that right here. Now notice how they call it absolute value of a, because even if the a value was -2, that's going to stretch it. See how it got more narrow? It was -2. It got narrower than the parent function. So when they put the absolute value bars around it, they're saying don't worry about the sign. Just if the number's bigger than 2, it's going to get narrower. And we'll get a vertical shrink. It will actually get wider if the a value is less than 1. So wider, we would talk about something like that. It would be really wide. This would be really narrow. This one would be narrow. This one would be wide. And we have a translation. Horizontally, h units, and vertically, k units. So we can come to our final equation, which is y equals half absolute value of x plus 2 minus 3. I know by looking at this, remember my equation is a, absolute value of x minus h, plus k. So my a value is considered the half, so I know it's going to make it, it's less than 1, so it's going to make it wider. My h value, this says plus 2. So for us to get a plus 2, we could consider this to be x minus a -2. So that means the h value is actually minus, because remember the formula has x minus h. So for this to be a plus, we needed 2 negatives to make a positive. So my h value is actually -2. And same idea for my k value. My formula is plus. Since the equation is minus, it has to be a -3. So I know my vertex is going to be at -2, -3. You could just go straight to -2 and down to -3 and put that in there. We labeled our point -2, -3. Now we're going to have this slope of a half. Our slope is rise over run, so we go up 1 and over 2. Up 1 and over 2. We can continue that all the way to the edge of our graph. And then on the other side, remember it always makes a V shape. Absolute value always makes a V shape for the graph. So here we're going to go up 1 and we go the other direction 2. Up 1, the other direction 2. That's going to look like so. So y equals half x plus 2 minus 3. That is how we graphed our absolute value function. This is as tough as it gets. The only thing that we could add to this, I guess, to make it trickier is if the a value was a negative and it would open downwards.